Moving on to geometry for first grade, there's just one main cluster here, reason with shapes and their attributes. So we need to distinguish between defining attributes versus non-defining attributes. Build and draw shapes to possess those defining attributes. Compose two-dimensional shapes or three-dimensional shapes to create a composite shapes and compose new shapes from the composite shape. And then partition circles, rectangles into 2 and 4 equal shares. Describe the shares using words halves and fourths and quarters, and use those phrases to describe them. Common manipulatives are 2 and 3-dimensional shapes, attribute blocks, pattern blocks, tangrams, geoboards, shapes, objects such as straws, gumdrops, marshmallows, popsicle sticks, etc. So I'm going to sort some following items and talk about them here. The baseball is a sphere. It is round like all spheres. I have an orange. An orange is a sphere because it's round like all spheres. However, it is the color orange, but not all spheres are orange. This food can here is a cylinder because it has circles on the top and the bottom. If I were to peel the label off and flatten it, the label is a rectangle. The toilet paper roll is also a cylinder since it has a circle on the top and the bottom. However, it is made of paper and not all cylinders are made of paper. The marker box is a rectangular prism because its corners are square, just like all rectangular prisms. A brick is a rectangular prism. It is really heavy, but not all rectangular prisms are heavy. The Egyptian pyramid is a pyramid because it comes to a point at the top. However, the food pyramid is not in the shape of a pyramid. It is flat, so it's not a real pyramid. Here are 4 triangles on the left. What do all of these triangles have in common? Take a moment to pause and review and look at the triangles on the left and look at those that are not triangles on the right and complete the sentence. All triangles blank, but only some triangles blank. Pause the video, write some ideas down, and come back. All triangles have 3 straight sides, but only some triangles are small. First graders are very literal, so think about that as I'm going through some of these. Another option, all triangles are closed, but only some triangles are upside down. The formal definition of a triangle is a closed shape with 3 straight sides that meet at 3 corners. It is not important for students to identify appropriate names such as a right triangle or a scalene or isosceles triangle. We're just identifying basic shapes. Here are 4 rectangles. What do all of these rectangles have in common? Take a moment, jot some ideas down, take a look at the rectangles and those that are not rectangles, and complete the sentence. All rectangles blank, but only some rectangles blank. Pause the video and jot some ideas down and see if we can match. All rectangles have 4 sides, but only some rectangles are red. Or, all rectangles have 4 corners, but only some rectangles are tall and skinny. The formal definition of a rectangle is that they are closed. Another fill in the blank, I'm sorry. All rectangles are closed, but only some rectangles are short. So the formal definition. A rectangle is a closed shape with 4 straight sides and 4 square corners. Here are 4 squares. What do all of these squares have in common? Take a moment to review the squares and those that are not squares and complete the sentence. Pause the video and come back when you've got them filled in. One option might be, all squares have 4 corners, but only some squares are blue. Again, literally, they will see a blue square and think that all of them could be blue. So identifying that only some are blue is important. All squares are closed, but only some squares are turned. A square is a closed shape with 4 straight sides and 4 square corners. The 4 sides are the same length. Putting shapes together creates what we call a composite shape. Using tangrams is a perfect way to help students solve, create, and identify that the entire shape is one unit. In the manipulative folder, click on the tangram template to print and cut out your own pieces, or use our virtual manipulatives. Once you've done that, take a moment to watch Grandfather Tang's story located in our lesson. If you notice, the tangram here is consistent of a large square that is subdivided into triangles, a square, and a parallelogram. Once you pause our lesson video, go and watch Grandfather Tang's story and then come back. We're going to talk about something. Now that you've watched Father Tang's story, can we recreate some of the shapes from the book using just one set of our tangram pieces, such as the rabbit, the goose, the lion, and the turtle? Take a moment to pause the video and use your tangram pieces to put them together. I'm going to see if I can't recreate the turtle. So it looks like I need the 2 big I might have to move these up here. Okay. We need the 2 big triangles. Line them up here. It looks like I need a square that can line up at this point. These are great puzzles for kids to problem solve, manipulate pieces with. Notice that not all of them actually have to be turned when recreating images. Oops. If you have these cut out and printed out in front of you, it would be easier just to manipulate them with on your table in front of you. But we get the idea of what it might look like. Students definitely like to play with these a lot. If you have use Pinterest or Google, you can find all kinds of different tangram puzzles to put together. Some of them actually have the lines on them, so students, especially in the younger grades, can line them up and get used to the shapes of them, and some of them just have the basic outline and they have to figure out which pieces go in between. So here's our turtle. Take a moment, go through the rabbit and the goose and the lion, put your pieces together, just play around a little bit with them. Our homework. You're going to print off the shape on the left, the house, using the document provided in the house discussion board. Using a pencil or pen, partition by drawing lines on the house into shapes that could be and how many of each shape you would need. Is there only one way you're able to create the picture? Make a list of the shapes needed. Partition the house. Try again using a different way to partition. Make a list of the shapes needed and how many of each shape you would need. Then scan and upload your two solutions in the discussion board. Take a moment to view your classmates' ideas and comment on one other student's shared idea. You'll notice that there are a multiple of different ways to create this house using multiple different types of shapes. So be creative, and I look forward to seeing what you come up with. For this next activity, I want you to find a sheet of paper, just any old regular sheet of paper. How can you share the paper equally so that you and I get the same size piece? Think about that. Then fold your paper to show how you and I get the same size. Reflect a little bit. How do you know that you and I will have the same size? How are you sure of this? Reflect. Perhaps you folded your paper in one of these ways, diagonally, straight down the middle, known as some of you may have heard of the hamburger fold or the hot dog fold, top to bottom. No matter which way you folded, we notice that there are two equal parts. What can we call each part of our rectangle here? What part of our paper? Since each piece is one of two equal parts, or half the rectangle, we will call the shares halves. If you and three friends want to share a cake so that you each get the same amount, how much can each person have? Well, how many people are sharing the cake? So there's you and three friends. So that would mean there are 4 people sharing the cake. What does our picture represent? Here I have a circle here. What does this circle represent? It certainly could represent the cake. Knowing that a cake isn't always a circle. Sometimes a cake is in a rectangle, sometimes a cake is in a square. Partition the cake such that each person has the same amount. So we could cut down the middle, cut side to side, or it could look like this. Just a little rotated. Either way, we need to make sure that there are 4 equal parts, one for each person. What are these parts called? Since each piece is one of 4 equal parts, we will call these shares fourths. To follow up, using the 1MD and 1G follow-up question discussion board, reflect using at least one paragraph per question, then respond to 2 classmates' responses. Question 1. Think about why predicting by estimating the length or height of an object is a valuable experience for K through first grade students. Why should students talk about their estimates and the mistakes they make with the measurement of their objects? Simple games and activities will help kindergartner through first grade students learn geometry concepts. Discuss 3 activities for the geometry domain, kindergarten or first grade, you believe will help promote student understanding and applications. Explain why vocabulary and terminology are critical to students' success with the study of geometry. And that wraps up our first grade experience. Next week, we'll move into second grade.